Quadrilateral quiz number 2, solution, starting with question number 1. Question number 1 is asking you to find the slope using two coordinates, and the two coordinate points are given, 3, 2, -5, -1. So you need to think about slope, which is rise over run, and remember the rise is the change in y over the change in x. And the y coordinates are 2 and -5, so it would be 2 subtracting -5 to get the change in the rise vertically, and then the run horizontally would be 3 subtracting -1, because those are the x coordinates. So then what you should notice is that you have the double negative, and the double negative means that you're going to actually add, so 2 plus 5 is 7, and then the 3 plus 1 would be 4. So that's why the slope for this one should be C, 7 over 4. The second question is asking you to think about what you know about perpendicular lines. It says two lines are perpendicular to each other if their slopes are opposite and reciprocal. Opposite meaning opposite sign, so that means one's positive, one's negative direction. Reciprocal meaning that the rise and the run are flipped. Those are the key elements, so this is actually true for perpendicular. You're going to need this idea for question 3, because question 3 says that we have the slope of 4 over 5. What's the slope if it's parallel and if it's perpendicular? If it's parallel, it has the exact same slope. That means that they never touch. So 4 over 5 would be parallel, and perpendicular would be the opposite reciprocal. So opposite means that it'll be negative instead of positive. Reciprocal means that it'll be flipped. So it'll be 5 over 4. So this one should match up with D. Parallel, same slope, 4 over 5, perpendicular, opposite, and reciprocal. So the answer should have been D for this one. Moving on to question number 4. Question number 4 is asking you to use the distance formula, and the distance formula is given below the question. You have coordinates -3, 4, and coordinates 5, -2. So you need to think about what x2 and x1 are. So x1 would be the x in the first coordinate, -3, and x2 would be the 5. So this one would be -3, that one would be 5. So when we plug these in, this one would actually be the 5, and the -3 would be this one. And then when you need to plug in the y coordinates are y2, so that would be this -2 would be the y2, and y1 would be the 4. So when you set this up, the distance would be 5 minus -3 squared plus, and that would be -2 minus 4 squared. So you do parentheses first. So in the parentheses it would be 5 plus 3, which is 8, so it'll be 8 squared. And then in the parentheses it would be -2 down -4 more, so it'd be -6 squared. Remember when you're typing this in the calculator to use the parentheses when you square them, because 8 squared would be 64, and -6 squared would be 36. They're still under the square root, which we do last. So 64 plus 36, if you were to add those together, would be 100. And then you have to take the square root. So when you take the square root of 100, the answer is 10. So the distance between those points is actually 10. Question number 5 is asking you to use the midpoint formula. So you need to label your coordinates again. So again, you're going to label the coordinate for -1, 2 would be your x1, and then that would be your y1. And then your coordinates for the second one, this one would be your x2 and your y2. So when you set this one up for the midpoint, I'm going to use M for midpoint. You add the x coordinates, so that would be -1 plus 3, divide by 2. And then the y coordinates would be 2 plus 8, divide by 2. So you add first, -1 plus 3 is 2, divide by 2. And then you fix that. And then the y coordinate would be 2 plus 8, which is 10, divide by 2. So when you simplify and divide, you will get 1 for the x, 2 divided by 2 is 1, sorry, and then 10 divided by 2 is 5. So that's why the answer was D. Question 6 is asking you true or false. It says if a quadrilateral was graphed on a coordinate plane, you could prove it was a square by using the distance formula to show that all the sides are equal length. If all the sides are equal length, that's one thing to prove it's a square, but that's also the same thing to prove rhombus. So if you want to prove it's a square, you have to go further and find the slopes of the lines to find the slopes are perpendicular, because you need to prove the right angles as well. So technically this is false. That's not enough information to prove that it's a square. Question number 7 is asking you the same thing, just about a different situation. If a quadrilateral was graphed on a coordinate plane, you could prove it was a parallelogram using the slope formula to show the slopes of the opposite sides are equal. And if the slopes of the opposite sides are equal, that does prove sets of parallel, which does prove a parallelogram, because that's all you have to prove for a parallelogram is that the opposite sides have the same slope, creating parallel. So this one would be true. All right, question number 8. Question number 8 is asking you to use that information to give and determine the shape that you're given on the coordinate plane. It says use what you know about the slopes and the lengths of the sides of the quadrilateral. So you have to find the slopes and then the lengths of the sides. So one quick thing to do is do rise over run to find the slope. So if we start with B, we're going to rise up 2 and run over 1, 2, 3. So the slope for this one would be 2 over 3. We want to compare it to the slope of the side opposite. So the slope of the side opposite would be A and D. So if we go down 2 and then left 3, this one will be -2 over -3, which does simplify to 2/3. So the top and the bottom are parallel because they have the same slope. Now we have to find the slope of the left and the right. So now we need to go from A and we rise up 1, 2, 3 and run over 1. So this would be 3 over 1. And then we want to do the same thing with C to D, but we're going to go down 3 and left 1. So this would be -3 over -1. So that is also 3 over 1. So the opposite sides are parallel. So right now we can say that it's a parallelogram because the opposite pairs of sides are parallel based on their slope. So we did the slope. So I'm going to get rid of the slope, because right now we know it's a parallelogram. We need to figure out if the lengths of the sides have the same measure. So now we need to use the distance formula to figure out if the lengths of the sides have the same measure. So now we need to look at a pair of sides. So if we look at B, C again, start there. The coordinate for B is +2, +5. So 2, 5. And the coordinate for C is 5, 7. And if we find the distance between those 2 points, we have to use the distance formula. So the distance formula is 5 minus 2 for the x-coordinates squared plus 7 minus 5 for the y-coordinates. So we simplify in the parentheses and we get 3 squared. Simplify in this parenthesis and we get 2 squared. So we have 3 squared, which is 9, 2 squared, which is 4, and the 9 plus 4 is 13. So this one is the square root of 13. So if we put that in our calculator, that's going to give us a decimal. So the square root of 13 is about 3.6. So that means, and I'll put the distance from B, C is 3.6. So now we need to find the distance between another side to see if it has equal sides. Because if it has all equal sides, then we can go specifically to a rhombus. We know for sure it's not a trapezoid because it has opposite sides parallel, has more than one pair. So now we need to see if DC is the same measure. So now we're going to find the distance on DC, which is 4, 4. So this coordinate is 4, 4. C coordinate is 5, 7 again. And we're going to find the distance. So the distance is going to be 5 minus 4 for the x-coordinates, 7 minus 4 for the y-coordinates. So if you simplify that, you'll have 1 squared plus 3 squared. If you simplify the parentheses, and then you square those, you'll have 1 plus 3 squared is 9. So you'll end up with the square root of 10. And if you were to try to plug that in your calculator, the square root of 10 is not the same as the square root of 13, because that is only 3.2 if you were to round it. So that means that the sides are not equal, so it cannot be a rhombus. So then you are left with a parallelogram, and not a rhombus, not a trapezoid, and not a diamond, because the sides have to be equal for the diamond as well. Moving on to question 9. Question 9 is asking you to, again, analyze the shape on the figure, on the graph here, and determine, again, the slopes and the side lengths to determine whether it is a rhombus, a square, a rectangle, or just a parallelogram. So you have to find the slopes again like we did on the last one. So we're going to go from Z up to W, and that's a rise of 1, 2, 3, and a run of 2. So this one has a slope of 3 over 2. The side opposite, you're going to go down 3 over 2 to the left. So this one will be negative 3 over negative 2, which simplifies to 3 over 2. So you have one set of parallel. And then in a different color, I will do the slopes of the other 2 lines and compare. So from X to W, I'm going to rise up 1, 2, 3, and go over 2. So this one is up 3, left 2. So this one is up 3, left 2. So that's negative 3 over 2. And Z to Y, if I go down 3, that's negative 3. And then I will go over 2. So those opposite sides are parallel. So I have 2 sets, opposite sides parallel, because they have the same slope. So it's definitely a parallelogram. So we can start with that. Now we just need to look specifically to see, is it a rectangle, square, or rhombus? So when you look at the slopes, they make right angles if they are perpendicular. So the slopes would have to be, so the 3 over negative 2 and the 3 over 2 would have to be opposite, which they are, and reciprocal, which they are not. So that means that the figure does not create right angles, so it can't be a rectangle, and it can't be a square. The only thing that it could be, if it's not just a parallelogram, would be a rhombus, and we would just have to do the distance formula to find the side lengths. So that's the last thing we have to do, is the distance formula to find the side lengths and to determine if the side lengths are all equal. If the side lengths are all equal, then we can say rhombus. If they're not, then we would only say parallelogram. So we need to look at the coordinates and find the distance. So we'll start with W and X, and we'll find the distance between W and X. We're going to find the difference in the X coordinates. So this would be 1 subtracting negative 1. And then the Y coordinates would be 1 again, minus 4. Take your difference. These two would end up adding to 2 squared. You subtract, you get negative 3 squared. So you'd end up with 4 plus 9. And when you add the 4 and the 9, you get 13. So you do the square root of 13. And when you calculate that, the square root of 13 is 3.6, like in the last question. So the distance here is 3.6. We just need to find the distance on the other side lengths. So we're just going to do the distance formula, and we would end up doing the distance formula 3 more times. I'm just going to do it one more time just to show an example. And if we go from X to Y, we'll find this side length, X to Y. And if we do the distance formula and we take the difference in the X coordinates, it would be 1 minus negative 1 again. And then it would be 1 minus negative 2. So when you subtract these, it's actually adding, becomes 2 squared. These, it becomes 3 squared. So this would be 4. And this would be 9 again. And this would be square root of 13 again. So this would be 3.6 as well. And if we did the distance formula 2 more times and found the length between Y and Z and W, then we'd have the same outcome, 3.6 and 3.6. So the answer is actually that it is a rhombus more specifically, not just a parallelogram. Last question, number 10. Actually, second to last question, number 10, and then we have 11. 10, you would go through the same process. You would take a look at the slopes and determine what the slopes are. So from A to B, we're going to rise up 1, 2, 3, and run over 1, 2, 3, 4. So this would be 3 over 4 would be the slope. And we compare it to the opposite side. This one is down 3 and over 4. So this would be negative 3 over negative 4, which is 3/4. So we have parallel. And then we do the same thing with the other two sides. This one, we find the slope. It'll be up 1, 2, 3, 4, 5, 6, 7, 8. It looks like 8. 1, 2, 3, 4, 5, 6, 7, 8. So it'll be up 8. And over 1, 2, 3, 4, 5, 6, it looks like. 3, 4, 5, 6, which simplifies to 4, negative 6 because it goes to the left. So simplifies to 4/3, and it'll be negative 4/3. This one would be the same thing. This one was actually down 8, right 6. So this would be negative 8 over 6, which simplifies to negative 4/3. So what you should be noticing is that the green are also the same slope, so that means that they would be parallel. So it's definitely a parallelogram. We just need to figure out if it's more specific, if it's a rectangle, rhombus, or square. You can tell by the side lengths, but if you did the distance formula, you would find that DC would equal AB and BC would equal AD. So it's definitely not a rhombus because the sides are not all equal, and it's not a square because the sides are not all equal. And if you look at the red and the green slopes, they are opposite reciprocal, so this one more specifically is a rectangle. Last question, same thing, same procedure. You're trying to find the slopes and the side lengths to determine how specific this shape is. So if we start with the slope of AJ, it goes up 2, and then over 1, 2, 3, 4, 5, 6. So this would be up 2 over 6. So this simplifies to 1/3. And then the opposite side is down 2, left 6, negative 2, negative 6, which is positive 1/3 as well. Left and right, you would go up 1, 2, 3, 4, 5, 6. This one is up 6, left 2, so positive 6, negative 2. That simplifies to negative 3. This one is down 6, left 2, or right 2. So this one would be negative 6, positive 2, which is negative 3 as well. So the red slopes are parallel, left and right, top and bottom. The green slopes are parallel, same slope, so it's definitely a parallelogram. We would need to next do the distance formula on all of these sides, and we would be determining that if we did the distance formula on each side, J to K, K to F, F to A to J, that all the side lengths would be equal. So it's also a rhombus. And then if we look at the slopes, so we can eliminate rectangle because all the sides would be equal if we did the distance formula 4 times. Then we look at the slopes and we notice that the negative 3 and the 1/3 are opposite, and then they're also reciprocal. So that means that the right angles would exist. And if the right angles exist because of opposite reciprocal slopes, then we can more specifically say that it's a square.